So far, we spoke about theoretical probability as well as experimental probability, but only with simple events, meaning only with rolling one die or only with talking about spinning one spinner, things like that. Now, we're going to focus on compound events. So, we're going to find the probability using a table in this situation. So, a compound event consists of two or more simple events. To find the probability of a compound event, you write a ratio of the number of ways the compound event can happen to the total number of equally likely possible outcomes. So I've already done this activity for us. So Jacob rolls two fair number cubes. All that means is two cubes that are numbered 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I have a green cube and I have a blue cube. I want to find the probability that the sum of the numbers he rolls is 8. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. As you can see over here, I'm just creating a table. Now, how many possibilities are there? There's 6 times 6 possibilities. So there's a total of 36 possible outcomes. Now, out of those possible outcomes, how many are 8? As you can see over here, 1, 2, 3, 4, 5. So it'll be 5 out of 36 possibilities. So what is the probability? All right, let's put theoretical probability. What is the theoretical probability of rolling a sum of 8? That's going to be equal to 5 out of 36. Okay, and that's basically it. Well, we're going to do something similar with the products as well. So start thinking about that. Now, let's go ahead and look at it a little bit differently. We could also find the probability using a tree diagram. You can also use a tree diagram to calculate the theoretical probabilities of compound events. So here's an example. A deli prepares sandwiches with one type of bread, either wheat or white, one type of meat, ham, turkey, or chicken, and one type of cheese, cheddar or Swiss. Each combination is equally likely. So as you can see, this lets you know that it's theoretical right here, equally likely. Find the probability of choosing a sandwich at random and getting turkey and Swiss on a wheat bread. So I'm specifically looking for turkey and Swiss on a wheat bread. So let me go ahead and give you my options. I could choose from different breads. From there, I could choose different meats. And from there, I could choose different cheeses. All right? So I have either white bread or I have wheat. Okay? Now, from that white bread, I could either choose ham, I could choose turkey, or I could choose chicken. And then also, from wheat, I could choose ham, I could choose turkey, or I could choose chicken. Okay? Now, from here, each of them gets a type of cheese. So I could choose cheddar or Swiss. And then for this turkey, it's either cheddar or Swiss. Chicken, cheddar or Swiss. Same thing, cheddar or Swiss. Cheddar or Swiss. And then lastly, we have cheddar or Swiss. Now, what am I looking for? I'm looking for a sandwich at random and getting turkey and Swiss on a wheat bread. So I'm looking for wheat bread, I'm looking for turkey over here, and then I'm looking for Swiss. Okay, now think. Find the number of possible outcomes in the sample space. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because these are the end products, I have 12 possible outcomes. Okay? Now, find the probability of getting turkey and Swiss on a wheat bread. Well, that only happens once, so it's going to be 1 out of 12. Okay? So my answer would be the probability, the theoretical probability of getting turkey and Swiss on a wheat bun is going to be 1/12. Okay? Now, I've done it with a tree diagram, but you could also think about it this way. How many bread choices do I have? 1 out of 2. How many meat choices do I have? 1 out of 3. And then lastly, how many cheese choices do I have? 1 out of 2. Because there's either cheddar or Swiss. So if I go ahead and multiply all of these, 1 times 1 times 1 is 1, and then 2 times 3 times 2, 2 times 3 is 6, times 2, it'll be 12. So this shows you mathematically why the tree diagram works. Okay? Now let's go ahead and try another example, a few more examples. You flip 3 coins and want to explore the probabilities of certain events. Make a tree diagram and make a list to find the sample space. Okay? So I have coin number 1, I have coin number 2, and I have coin number 3. I'm flipping 3 coins. Okay? So if I flip the first coin, what is my options? What are my options? I could either get heads or I could get tails. Alright? That's it. Those are my only options. For the second coin, if the first one I got heads, I could either get a heads or tails for the second one. And if I first got tails, once again, I could either get heads or tails for that second coin. Now, for the third coin over here, it's the same thing. I could either get a heads or tails. One more time, I could get a heads or tails. And then lastly, heads, tails, heads, tails. There are only 2 possible outcomes. So my tree diagram can only branch off 2 ways. Alright? So first, I had heads, heads, heads. That's one possible outcome. And then I got heads, heads, tails. So that's for this one, and that's for this one. Next, I get heads, tails, heads, heads, tails, heads, and then heads, tails, tails, heads, tails, tails. Okay? Next, I got tails, heads, heads, tails, heads, heads. This is going to take a while. And then tails, heads, tails. Let's just put this one down here. Tails, heads, tails. Then for this, I got tails, tails, heads, tails, tails, heads, and then lastly, tails, 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 tails. Okay? So, if we take a look over here, how many outcomes are there in this sample space? Well, I can see there's 1, 2, 3, 4, 5, 6, 7, 8. More specifically, it's these 8 over here. So there are 8 possible outcomes in the sample space. Okay? List all the ways that there are to get 3 heads. Now, how many ways are there in order to get 3 heads? Well, there's only one way. Okay? So, the probability of getting 3 heads is going to be 1 out of 8 possibilities. Okay? Now, what would be the probability of getting exactly 2 heads? What is the probability? The probability of getting 2 heads. Exactly 2 heads. So that's not possible. Here's 1 right here. Here's 2, 3, 3. Okay? So that'll be equal to 3 out of 8. Alright? And that's how you'll do it with coins. Now, let's go ahead and do our very, very last example. This one is going to be with spinners. Find the compound probability of the following events. The probability of spinning 3 and then blue. Okay? So, in terms of 3, it's going to be 1 out of 8 times for 3. 1 out of 8 times. How many blues do I have? 1, 2, 3. 3 out of 8. Okay? So I'm just solving this mathematically. So 1 times 3 is 3. And then 8 times 8 is going to be equal to 64. Right? Now, of course, over here, we'll see if we could simplify that 64. Can 64 be divided by 3? It can't. So I can't really simplify it anymore. So it's going to be a 3 out of 64 chance that I spin a 3 and then I spin a blue. Okay? Next, spinning even, then red. So how many evens do we have? We have 1, 2, 3, 4. So that's going to be 4 out of 8. Now I'm going to multiply that by the amount of red that I have, which is 1 out of 8. So 4 times 1 is going to give me 4 out of 64. 64 in this case can be divided by 4, so I'm going to be left with 1/16. So there's a 1/16 chance that I'm going to spin an even number, and then directly after that even number, I'm going to spin a red. Lastly, spinning an 8 and a yellow. So how many 8s do I have? I have 1 out of 8, and I have 2 out of 8 yellows. Okay? Now, let's go ahead and simplify this first to 1/4. So that's going to be 1 over 8 times 4, which is 32. Right? So there's a 1 in 32 chance that I could spin an 8, and then directly after that 8, I'll spin a yellow. Okay? And that's it for compound probability of theoretical events.